Welcome to today's episode of On the Rocks. Today I'm excited to introduce you to Benedikt Kirchgaessler, the founder and CEO of Cyanide. Benedikt has a background in chemistry, finance, and entrepreneurship, and he's grown the company into a global organization supplying 7 of the top 10 Fortune 500 mining companies after founding the company in only 2016 while still doing his chemistry studies at the University of Zurich. Benedikt's aim was to provide an advanced Internet of Things-based cyanide process monitoring solution to gold and silver mines. In today's episode, we talk about the basics of cyanide and how it's used in the mining industry, as well as how IoT monitoring solutions can help miners significantly increase metal recoveries while reducing operating costs and environmental footprint. Pour a glass of coffee or bourbon or water or whatever you prefer, and let's jump in. Well, Benedikt, thanks so much for calling in here on The Rocks. We're excited to have you talk about a super exciting topic, cyanide, and what you do at Cyanide. So thanks again for joining us. And what are you drinking tonight, your time?
I'm just on my coffee right now because I still have a long drive
Yeah,
ahead of me.
no judgment, no judgment.
Yeah, thanks so much for having me. I'm really excited for the show tonight.
Yeah, what I'd love to start with before we get into a little bit more about the technical specifics of what you do is for people who don't know, can you explain, first of all, what cyanide is and how it's used in mining? Because I think it probably just freaks people out to even hear the word
Sure.
cyanide.
Yeah, sure. No, I'm actually very used to that because what we do is actually quite niche, especially for for our region here in Switzerland. Like we don't have a lot of mining. I don't think there's any gold mining in a radius of about like a couple hundred miles here at all. So I think the most important thing about cyanide to know is that cyanide is a very simple compound. It's just nitrogen and carbon,
Mhm.
and it occurs naturally. For example, you have tons of fruits like almonds, for example. There's this characteristic cyanide smell. What most people do know, it's very toxic. But what I think is not so much known how important it is for mining, especially for gold mining, because for I would say about 80 to 90% of the global industrial gold production, so setting aside all the artisanal and sometimes not legal gold mining that happens, you use cyanide to chemically extract the gold from the ore. Because as you might
Mm,
know, in about a ton of ore, you have only about 2 grams of gold. And so
mhm,
in order to extract this, it's not really that efficient anymore to go to like a river and trying to sieve it out. It's because you have this magnitude of rock or like ore versus the gold that's actually contained. So you need to come up with a very efficient way, and the cyanide is still the best method of cyanidation, still the best method known today, or most effective method to extract gold. So you can extract over 95% of the gold contained, which is very efficient.
mhm.
And there's, of course, everybody knows it's very toxic. But in an industrial setting where people are aware of the dangers and usually, it's managed well, monitored well, accidents and especially environmental incidents are quite rare. However, there have been some in the past, and it's gotten also a lot more stricter. But I think this has
Mhm.
also helped to bring awareness in the industry.
Yeah, and I think for if people can picture, you basically have to trickle the cyanide mixed in a solution over the crushed up ore, right? To
Hmm.
basically leach down through the ore and collect the liquid that comes out on the other side,
Exactly.
right? And then you extract the gold from the leaching fluid.
Exactly. Yeah. So that's I would say the process in a nutshell. So you have different ways you can do this in a tag. You can do this more on like a leach pad, but the process that you just described is I couldn't say it better. It's just this way. Like you add the cyanide to it with a few other chemicals, and especially you have to think of it as like a specific like a washing like a detergent that
Mm.
attaches to the gold and just takes the gold and leaves the rest intact.
And then in most situations, the cyanide is essentially recycled, right, and reused in
Yeah, that's something that the industry is striving to. I think it also makes a lot of sense because you have to think about transporting cyanide is quite. I would say it's quite hazardous because a lot can happen. Like if you have if a truck with the cyanide crashes or something like this, it's not that great. So it's also quite expensive to transport it.
Mm.
So you ideally want to, especially most mines, they're not like, just around the corner of like a large urban center. They're in the middle of nowhere usually. So getting the sauna there is also quite expensive, especially nowadays fuel prices. Transporting it gets very expensive. So if you use a sauna that's already there, it's even better. And from a cost perspective, it was in the media actually. One of the biggest ingredients, like what you need to make cyanide, is natural gas. And especially with Europe, with the conflict and sort of like the skyrocketing in natural gas prices, there was a few of the cyanide plants that have been shut down here, and it's been a situation that's exacerbated over the last couple of years that there's a supply gap for cyanide because you cannot construct any more factories because nobody wants a cyanide factory in their backyard necessarily. So there's a
Yeah.
limited supply of cyanide, but the gold mining industry needs more because the ore is getting more and more complicated, meaning they consume a lot more cyanide. And if you don't make sure that you really are on top of this process to figure out exactly how much cyanide you need, your operating costs are gonna skyrocket.
So, how did you end up doing this? Because it seems like a really specific line of business
Yeah,
to get.
I've been asking that myself a couple of times recently. And it's yeah, because it's not very classic. So I actually my first career sort of, I studied business, and then I went back to school and studied chemistry.
Mm,
And in my last year while studying chemistry, I came across a sort of a paper or some research that was in a group at the University of Zurich, where they looked at a new way of detecting cyanide. And I didn't really have much to do with cyanide, but found this project very interesting, and I asked the group leader, the professor, if I could join his group for a summer to make a small like a small summer research paper on it, like in a research project, and start working on this. And I thought, like, wow, there might be some real application there. And for me, it was always, doing science. It was always like I never seen myself as becoming like a professor, or always
mhm.
wanted to do something that has a real application. So like, hey, yeah, maybe I'll talk to a few people about this. And at the beginning, it was more about food safety testing. I mentioned earlier that you have also cyanide and almonds, for example. So you need to also test them for
Yeah.
make sure that nobody gets accidentally poisoned, especially for for infants. That's a problem. So I focused on the food safety part, and not knowing about all the cyanide in mine, I had no idea. And then somebody connected me with a mine in Peru and said, like, you have to talk to these guys. They have issues of monitoring their cyanide. They want to make sure that there's no harm to the environment done. Can you talk to these guys? And that was back in 2017. And I thought, well, I can talk to these guys a lot, but it's probably not going to work out if I just keep talking to them. I have to go there. So I just got on a plane. 2017, flew to Peru, and then spent 2 days in the mine there, and really understood, how important cyanide is for them and how important detection is. And I think this is where it's all started out. Back then, we didn't really have this whole cyanide monitoring solution that we have with the online platform and the handle analyzers. More of like a research prototype.
Mm.
And yeah, and I think we started building it from there. So I think we had the first working solution ready back in 2020. And then 2021, we started commercialize it. Everything was a little delayed because you can imagine, like, we have to travel to the mines. So in
Yeah.
2020 and 2021, it was not the easiest for us, but we made it work. Yeah, so I think this is how I got in there. It was just somebody connected me to someone that had a problem, and it was really helpful for us because I think now we do it now. 90% of our business, of our work, what we do every day is connected to mining.
Mm.
We have a few almond producers, and we're even like a brewery among our customers because they use like, if you use cassava, you maybe like this like root
Yeah.
vegetable. It's like it's very, especially in Africa, it's a very well-known staple. Here like in Europe, like you find it in the supermarket, but not that much. But they use it to brew beer as a malt, basically. And so they have
Okay.
to do the same thing. They have to make sure, because the yeast doesn't like the cyanide. So we also deliver one of the largest brewers in the world with our kits. But as 90% is about mining.
So interesting. Yeah, that overlap between the food and beverage and mining.
Yeah.
Would not have thought that. And then I would assume once you started working with the mining companies, is that where you started to build out this larger monitoring system once you saw the common needs? And I mean, what were the mining companies telling you they needed that was such a clear gap?
Yes, I think what the main point was what I was doing from starting new companies from now. So I'm always was focused very on the commercial side. Of obviously at the beginning, I worked a lot in the lab. I did a lot of production myself, and we did it by hand.
Hmm.
Um, I think the one thing with product development or like developing a new product is you first have to understand like what they tell you what they need and what they
Hmm.
really need. Like I think there's a slight difference that you don't always get the 100% because it's sometimes difficult to understand exactly what you want. Like you have to sort of synthesize it from different angles and then try it in a fast way. So what we always try to do is that whenever we build something, we try to ship it right away. Like even if it
Hmm.
was not perfect. Like somebody always said to me, like if you're not ashamed of the first versions you shipped, or like because they were like a little clumsy and didn't look like it, but they worked well, then
Yeah.
you launch too late. So we always try to iterate very fast and shipped it out. And basically, what we did at the beginning, we just had a tool that measured cyanide because we thought, well, this is what they're going to need because if they get the right values, the mines that everything's going to work out.
Yeah.
But then we realized that the problem was not really the measurement itself, which was not working that great, but it was the whole link between making the measurement and then process control that this has to be automated and that the decision making has to be changed from a heuristic, like experience driven way to a data driven empirical way. And that's I think, what we're still doing, what we're still working in progress. That as we went to the mines, we saw that the need is more for re-automating that part and helping the miners make the right decision in terms of, like, do I need to add more cyanide? Do I need to add less cyanide? Do I need to control the pH, for example? So there's very different, I would say, knobs in this process that you can turn in
Hmm.
order to make sure that you re-operate your process at the most efficient level.
And maybe explain that a little bit more because I think most people think
Mhm.
once you have a mind that operates, like it operates the same way all the time, right? And the mill just goes the same way all the time. And in reality,
That's the ideal case,
it
yeah.
doesn't, right? Yeah,
Yeah.
because based on the ore coming in and maybe the ore changes depending on where you're pulling it.
Yeah, I think
Yeah.
I think that's a very good point because that's something that happens, that the deeper you go, for example, the composition of the metals are going to change. Maybe you get a composite, maybe from different sources that you put it together, and
Hmm.
that's ideally the reason why we are in business is because there are changes. So what you said already is like the ore can change, but also you have variations in temperature, you have variations in humidity. They're not the biggest, I would say, the biggest influences, but they all have an impact. And because it's a dynamic system, you need to monitor it.
Mm.
And because what happens, I'm just try to explain these two cases. So um, imagine like you have a very high cyanide concentration, for example, because like your metal content dropped, meaning that you have an excess of cyanide that you don't need. What that means in like a case where you don't recover cyanide, which I have to say, like most of our customers or partners, they don't use cyanide recovery because it's still not cost effective. So it goes to the tailings. So for them, the ideal case is they have the minimal amounts of cyanide from a cost perspective and also from an environmental perspective, because it's also in a cost perspective, because if you have too much cyanide coming out your end, like you need to add more chemicals to destruct it. So you don't want an excess. I would say that's usually about 30 to 40% of the value that we bring. But what's more critical for the mine is that they extract all the gold, because you have to think of this process like a one-way street. You're not going to process your tailings again, at least not in this lifetime of the mine. Maybe somebody else in 30, 40 years will, like we do now, but not right now. So what
Yeah.
happens if the cyanide concentration drops because you have suddenly more metal? For example, also other metals, they will consume the cyanide, like copper, and you
Mm.
don't react quickly enough. Then because you have not enough cyanide, there's not enough cyanide to extract all the gold. So the gold will leave the circuit or the process unextracted, and
Recovery
basically
rate.
lost, yeah, your recovery rate drops.
Mm.
And this is where we come in, because we can deliver an accurate, reliable result in a very fast fashion. And what's
Mm.
traditionally the issue with cyanide monitoring is that most methods, they are very much affected by other metals that are present. And that's an issue because usually if you mine gold, you don't only have gold, you usually have some copper, you also have
Right.
sulfur. And some the methods that this used to be done traditionally, this was also for me the reason 5 years ago to go into this business, the methods to do this with traditionally, they are affected by this. So when you have copper present, it will give you a false result. And that will lead to the mine making the wrong decision in the process control and using not the correct amount of cyanide. And that's what we basically help the mines. We help them to make the right decision.
Yeah.
And we started out, we just wanted to deliver the measurement data, but now what we want to do, we want to help them to automate it so that our result is directly connected to their control platform. So, for example, working with a very large provider, ABB, so it directly connects to their control platform, so it would automatically not only deliver the information, but also make the necessary change to the process. So there's no time lag anymore. There can be no mistake, and that's sort of what we're seeing as the solution that we currently have. Solution to the problem that we currently have with mining is a very resource, very energy heavy process. So you need to try to work as lean, as efficient as possible.
And have you seen a quick rate of adoption of that new technology and approach within the industry?
It depends very much. You have always some early movers, with early movers in mining still being, I would say, sometimes very impatient. But
Yeah,
it just takes some time because safety is the most important, say motive or most important paradigm, safety first in mining. So the organizations are not traditionally built in a very agile or lean way. So it's mostly about safety and conservative process. So it will
yeah,
take some time. You need to jump through some hoops. You need to be accredited as a supplier. Then you need to get the permits to go to the mine. So there's some things involved that make it more difficult than just going online and buying a subscription to a software.
yeah,
But I would say we're happy with some partners. With some it just takes a while. And then also you have to think about the way that this was done for 20, 30 years hasn't changed at all.
right,
Like
yeah,
so, and then we come in and I haven't worked in mining for 30 years, so I cannot go to a mining engineer and tell him like I have 30 years more experience than you, so you're just going to do what I tell you. We can just go there and say like, look, this is how we do it. We think this is for this and this way. It works great. Here's a few of our users that already use it. Why don't you give it a try? Because I would say we see us more as a solution partner, not necessarily as like a hard sell. It's like, yeah, you have to take this, and it's more like they can try it out without any commitment. They can see like, does it work for your process? Yes or no. Do you see results? Yes or no. If you don't see results, well then it was great talking to you, but you don't need to spend your time on it if it's not productive for you. And that means we have to do a pilot, or we usually want to do a pilot. So there's already 3 4 months on this. So yeah, I would say it could be quicker, but I think the reasons why it's slow, they make sense.
yeah. No, I think that's where, from a business case perspective, you look at it, you say you're making things more efficient, more environmentally friendly, like what would be the resistance? But again, if these areas have been operating for decades with the old way,
Hmm.
it's hard to get any organization to change,
Hmm.
but in particular with operations, right? How is this going to our day-to-day operations? So kudos to you guys for getting those brands on board. Now, I wonder when you think about that, and I'm sure you see lots of other opportunities in the industry because you're kind of there meeting with folks, seeing other ways to help them become more efficient, and more sustainable. What are
Hmm.
your thoughts on digital technology in general at the operating mine level? Like, do you think there's a big opportunity there? There's a lot of talk. There's a lot of talk about
Hmm.
digitization and automation, but what are you seeing?
So for me, like when I said earlier, like I got into mining by accident.
Yeah.
Like I got in there by accident, but I stayed there by choice
Mm,
because it's been now, over 5 years since that fateful trip
yeah.
to Peru. So I stayed here because I think it's one of the biggest challenges that we have to achieve what everybody set out to do. Like we just had the World Economic Forum in Switzerland. And, there's always like a big controversy around it.
Yeah.
But I think what everybody I think is understands that the way of consumption, the way, that we have done things, and it needs to change because there's a new set of challenges, for society.
Yeah.
And if we would just, like without me sort of like judging, like we're making a standpoint on that, if we want to transition to, for example, like electric vehicles, what's going to happen? This is a shift of energy from fossil, like petrochemical, like hydrocarbon fuels,
Yeah.
to like where the energy is stored and burned. It's a very efficient, very, very nice. You have a lot of energy in a very small compartment. You want to change that to electric, like, which is not that energy dense yet, which is a bit of a problem, but it's mostly, not mostly, it's 100% metals. So you're just changing everything, like from the oil that you drilled, you're changing it to metals. And if you look at the forecast, for example, for copper only, it's simply not, the capacities are not there yet, like, or for lithium, it's not there yet. And nobody's really talking, it's not that clear, and everybody says, yeah, we need more electric vehicles now. But so I'm just coming back to the point now. Pretext is we're going to have one of the biggest mining operations of, I think, last centuries. Like, I haven't been around for that long, but I have a feeling that it's going to get more and more important. But mines, like, I can only speak, like, what I've seen in gold and silver mining so far. They're not at that level yet where you would see like like a chip manufacturer or a different manufacturing company, which level they're at yet.
Yeah.
They're still operate in a very siloed way. They're not very open with their data, like machine learning, or like a lot of different applications where you see already in all the industries. They're sort of far away because everybody knows how difficult it is to break into the mining industry. Like when you have something like a new technology that's sort of like used in pharmaceutical or chip manufacturing, it's they're much quicker because they're already building on an innovation. But mining, they're like, oh yeah, not so sure, and I don't want to be the first one to use it because it's very conservative. Because as long as you're doing as well as your peers, you're fine. And that mindset needs to change without sort of like that the peers force it on you.
Yeah.
And I think for the digital part, I think there's so many applications, and I think there's a few companies already that lead very well. So I've been in a few mines in the US and Australia where I've been really impressed. But I would say the average mine is still very much offline, still trying to things in a very conservative way, not changing too much. And I think the energy gains, because what's the nice thing about digital technologies, especially mining, is all of the hard assets are already there. Like, you don't need to buy a new grinder or a new mill. You just have to make sure that you use it in the right way. And it's the same what we're doing. So we're not selling any machines. It's also why we can afford these pilots. Like it's a small unit that we ship. We can ship it there. So it's usually, for example, like Nevada is one of the main hubs for gold mining in the US. It's there in 4 days from here. They can try it out. It takes a day to set up. They can try it out after 2 or 3 weeks. And I think this is with most digital technologies, it doesn't take that much effort, but the mindset, sort of like, how do you want to try something out, is not always there yet. And I think this is the first thing that needs to change, because a lot of companies, especially young companies like we, it's very hard to survive in the mining industry.
Yeah.
Because you have very short funding cycles, 12 to 18 months, and you need to make progress in that time. And if you need to wait 12 to 14 months until like a certain customer brings you revenue, it can be quite a stretch, because your investors, they expect you to make the results. And if you have this mismatch, it's going to be very hard. And I think here in Switzerland, we maybe have 2 or 3 mining companies.
Yeah.
Because it's just, it's sometimes very hard to find the right support for it.
No, we see that on the prospector side too. It's a much longer decision-making cycle. And I think part of it is because, rightly so, for many reasons, mining approaches things from a risk mitigation perspective as opposed to an innovation perspective. And sometimes it's not so clear that you can take a risk on an innovative technology and also reduce your operating risk or your financial risk, opportunity loss risk. I mean, there's lots of ways, but that culture still isn't there yet, right? But it will have to change, I think, because with new types of investment money coming into the mining space, there are different expectations about technology, adoption and innovation, and you've got to be able to show more data faster about what you're doing and how it is.
Yeah, no, I think there will be a paradigm shift, because there's only so much you can do, with with hardware, like saying, like, oh yeah, you're gonna, select better ores, do better picking. But in the end, you need to make sure that you make the right decisions. And what we see very often is, especially in medium-sized operations, so if you go into really big operations, they're much more inclined, because for them the return is much higher, because if they make a small switch, it makes a huge impact. The lever in a way is very high. With small operation, you have still very experienced, like, senior mining engineers, and the way that it's done is because a lot of things they cannot measure, they don't have the right data, or they don't have the right data available. They do it in a heuristic way. They say, like, yeah, so I've experienced this before, there's this theoretical model, and I think this applies here. But there's not really data driven, because in the end, like, for example, cyanidation, it's very clear. So you have you set a certain amount, you set, like, where now you even have a system to measure gold in real time. This is very interesting, because you can basically always check, is the gold recovery rate, is it coming out the way that we expect it to be? If not, we need to change something. And so this is available now, and you can basically optimize it in real time. It means you build like a self-optimizing system that basically checks, oh, do I have the right amount of cyanide? Do I have the right amount of, have the right pH? So do I need to add lime? What's my temperature? And you can all put it together, and it's actually not that difficult. Changing that mindset and saying, like, look, guys, this is what we want to try right now. I want to go away from the system where I said, like, okay, like, I think we should do it this way, or we shouldn't. Like, let the data speak for itself. And I think this is changing. We've been working actually with a few mines which are very interested in that, because they realize this can be a competitive advantage, that you're an early mover, that you're ahead of other mines in the area that don't do it this way. Because even though it will not show results, like on the first or the second day, and nobody will see it right away, in a few months' time, when you have the data, you can use that data to build a model, and then have an operating system. You're ahead of the competition. And I think when it comes down to mining, so at least what I know about the investment side of gold mining, everybody looks at the all-in sustaining costs per ounce.
Yeah.
And digital process control will have a huge impact on that.
Yeah. Do you have any examples or metrics you can share on that? Like, what kind of reduction in all-in sustaining costs?
So what we usually seen in our the data that we get back from mines, because that's the interesting thing. Like, we're not really having to sell much. Like, mines can see themselves, like, look, this is your process. It goes up and down. It has a huge variation. When you don't use a good monitoring technology, it doesn't necessarily have to be ours, but like, you should monitor it. And if you don't, and then they see, like, oh yeah, it has very high oscillation. You don't want oscillation, you want a nice and stable process. And if you calculate that, so we did it for one mine for a few weeks. We calculate that. So what we saw on average is that, on average, if you would have dosed based on our control input and not on the legacy one, you would have increased your recovery rate by 2%, which can be quite significant.
Yeah.
Especially because you only have to make changes in the control.
Yeah.
This is, like, financially, I think the biggest impact, because it adds a significant amount of gold.
Yeah, I mean, if you can,
to you.
Yeah, that adds 2% to your profits, essentially.
Yeah, exactly. And then on the other side, and this is like what's for me is quite important, because I think we have, having studied chemistry, you learn everything about like that mass cannot be destructed. Like, there's always going to be the same mass. It's going to be a different shape. So you have a finite amount of resources, and although it's financially, it's not at this stage of cyanide, it's already quite expensive. So you're looking at $2,500 to $3,000 US dollars per ton of cyanide, and it's still manageable, I would say, for most mines. But you still should be careful. Like, you should not waste it. And there we have, even because mining traditionally, so the traditional paradigm in gold mining has been, for the last, I would say, 100 years, because the cyanidation process is actually that old, is to just use an excess of cyanide, just throw huge amounts of cyanide on it to be sure that you recover all the gold. But that doesn't work when you have a more complex ore, what I've explained earlier. And so we're trying to stop that as well. And there we've seen that usually we can reduce the cyanide consumption by to 25%.
Wow.
Which was about, until I would say 2 or 3 years ago, it was not that, wasn't just like financially was interesting. Okay, I have to spend less on cyanide. What's interesting now is that it's sometimes very hard to get more cyanide. You get a certain amount of cyanide, what you have agreed with your supplier, and it's hard to source more. because you only have a limited supply. You don't usually ship cyanide like in some cases, but usually you try to source the cyanide locally.
Yeah.
And there is some ways, to get. I would say it's a bit not sketchy, but it's like a bit more difficult. They can get cyanide from China or Russia, but usually has a different quality specifications because they have use different standards. But usually it's not so easy to source more,
Yeah.
and meaning if you save cyanide and you have more cyanide available, then you can also process more ore.
Right.
So you can also increase your throughput. And that's something that we've seen recently as an advantage.
Well, and I would imagine, again, it may not be a huge impact, but you would have a better ability to forecast your cyanide usage and
Exactly.
when you need more accurately as well. Better planning. Yeah, no, I think that's really cool. I mean, again, I think when folks listen who are more on the investor side, right, and all-in sustaining cost is definitely something that people pay very close attention to. It's how you essentially benchmark a company against their peers, right, as well. What are their costs look like? And I think when people ask, how can I tell a company that's innovative and forward thinking from one that's not? It's like, are you looking at things like this? Are they looking to reduce costs by bringing in new innovative technology, right? If a company's not, are they, then there's a ceiling really, or it's going to be hard to reduce that if you're not doing something different.
I think there's one. So what we realized with a few mines is that their cultures just they don't want to show. Like they realize, okay, something is not going well, but they don't want to show it to the outside. They don't want to have people too quickly in their mind. And then you have, especially larger with like a lot of corporate function, you have an innovation manager, and this is great. This is like a first step. But there's usually a very big disconnect. If you have the people that work on site, they respect people that go with them on site that are there. And somebody from corporate is always going to be there's, I wouldn't say distrust, but sort of like they're going to be careful because they realize they have very different sets of challenges and interests than what people on site have. So I think what's very important both for companies like ours that want to go into mining, because there's a lot of companies that have amazing products that can be used for mining, but they don't want to go there yet because it requires large investments and long stamina.
Yeah.
Is to try to go directly to the site. And also for the mines, I think if they would be quicker, in setting up those pilots, it would be a lot more interesting for young companies to start with innovation to make it, because the friction cost is so much lower. But if you have to jump through all those hoops, and you then first talk with someone from innovation, and then they try to push it onto like a site, and then the site is like, no, we don't want to do it. And I think this is so for investors, like if an investor wants to find out if the company is really innovative, I think you have to look really at the site operation. You have to understand what kind of technology do they use there, what do they use for process control, like how are they set up, instead of like trying to read some glossy paper where they say, oh, this innovations. It's really about what they use on site and what the mindset of the people's on site that actually do the operations, and that's going to be the decisive factor if innovation is successful or not.
No, I think that's such a good point. I mean, if folks in the industry want to encourage new innovative companies, people to come in with new ideas, like kind of meet us halfway and try to help speed up the timeline, because I definitely can sympathize with what you're saying. Like it's even just the follow up. Like you're the big company, you've got things planned out over the next 4 quarters, right? Just let us know, or let maybe like here's when we can do this, so you can there's management of expectations, right? Just help us get there a little faster.
Yeah, and it's in their interest, because like if it takes me 3 or 4 months, like I have a staff coworker of mine on a certain project who also needs to follow up. It's a cost question, so I need to recover this cost. So it's going to make it a lot more expensive for the mines.
Yep.
And mines always complain like, yeah, buy something for this, and it's also sold in this other industry, and it's way cheaper there. And I say like, yeah, but like getting to this place, if I want to sell something, it's faster, and I don't need to travel, I don't know, 22 hours somewhere to the middle of the desert in Australia. So, and I think the second part, it's inevitable, but I think the first part, like if you're if your mentality is like, yeah, try it out a little quicker, your process. There's nothing to be afraid of, because most gold process, they're the same. They have the same sets of challenges,
Yeah.
because they're if you have 6 mines in the same area operating on the same ore body, they're all going to share the same characteristics. And so if we're already working with another mine,
Yeah.
we already know what kind of challenges they have when it comes to cyanide monitoring.
Right. Yeah, and I think somebody had a great idea once, that it would be awesome if the companies all agreed that, hey, a pilot at one project is not all that different from a pilot at another one. So, like,
Mhm.
can the industry start to agree that if something's been piloted and proven to work at a few different companies and different sites, do we have to pilot everything? Like, because it also adds on to that sales cycle and the timeline for adoption, and certainly sites require that because there's different and flow processes and all that stuff, but I
Mhm.
thought that was a great idea that at what point can we get consensus, right?
Mhm.
That this
Yeah, I think that's the ideal world, like you're preaching to the choir, like this is usually like my job, when I need to talk to our head of sales, and I talk to her and say like, yeah, look, like we this project was supposed to start there and there. Oh yeah, but we didn't get the address, we're still waiting on the customer approval, and so on. So of course that would be amazing if this would be all working at the same time. But in the end, I think you also have to understand the dynamics at the site. Like there's one general manager who has like one operation, and he's going to be responsible. And if something doesn't work, and he says, "Oh yeah, but this other side did this as well,"
yeah.
so I think there's always going to be a trade-off where you say like, yeah, you have to try to do it as quickly as possible
Mhm.
to be resource efficient, but on the other hand, you have to onboard everyone that's involved in the project. You have to have your champion that's gonna help you shepherd this through, and you want that it goes fast, but you cannot rush it. And if he wants to do, or she or them they want to do the pilot at their site again individually, then you have to accept it or move on. Like if it's not possible, it's not possible. But usually we try to accommodate, because
Sure.
the way we see it, we want to build long lasting relationships.
Mhm.
So because for us it's if a customer changes their system or doesn't work with us anymore after half a year, we're losing money, like, because we're rather for a long run. So we set this up. And also I think the biggest benefit of our system comes after like a certain time, when we have enough data, because then we can understand, if you see 2 or 3 months of continuous operation, we also see the challenges that happens, like if they, for example, load a different ore type, or if they had a shutdown and they start back up again, we can we can understand like how we can make these different changes in the process, how we can incorporate it into our model. And I think this is something that we're looking for. And so we want to build that relationship. And ideally, yes, we could build them at the same time with I would say like 12 sites in
Yeah.
a parallel. But the truth is, you usually have to go in pilot.
Yeah, it's one of the wonderful things about mining is the culture and the diversity of sites and different mines and operations, but it can also be, yeah, I mean, it's positives and negatives. Well, on that, Benedikt, I've been asking all of our guests, if you could, for your last question, if you could change one thing, just one thing about the industry with a magic wand overnight,
Mhm.
what would you change about the mining industry?
I think it's something that we've already discussed. I think I would try to change the mindset a bit, or take a bit not the fear, but the sort of like a being a bit afraid of new technologies,
Mhm,
trying to change it a bit more, that people are a bit more excited, that they realize, hey, there's something that we've been doing for a certain way. And usually people on site, they already know if something's needs to be changed or not, but there's usually no resources for that. So you have to meet production targets, you have to work the shifts, and it's really good sort of like for the administration for keeping it in production, but for the improvement is often very difficult to find the resources for that,
mhm,
because depending on the gold price, it can be quite a stretch, especially in more developed countries where you have high labor costs. It can be quite a stretch to have enough staff to also engage in innovation.
mhm.
And I think this is something that I think it would need a magic wand for that, because if you want more if you want more people on site, you would need more money. And if the gold price is not increasing, then this can be quite difficult. But this is what I would love to change, that you had the time to try to innovate, try to work on issues that are there, especially with the fact that mining is a very resource intensive industry. And as I said before, we have finite amounts, finite resources, at least on the metal side.
Yeah.
And this is something that I think I would like to change, this innovation, this like also awareness that mining they have to do something. Because very often when I'm asked, like, oh yeah, but mining, isn't that really dirty and like something a little bit sketchy? I say like, no, it's actually not the case. It's just they're just getting started on the whole innovation part. And if you could accelerate this,
Right.
it would have so many advantages. We could maybe meet the metal demand in the future, because we can produce with the same resources we have, we produce more efficiently. And in order to do that, we need the most effective technologies. And the most effective technologies are probably not the ones that they already know.
Right.
So if we could change this, I think this would be like a critical point. Just be a little more open, try more few things. Don't take stupid risks, of course, but
Right.
try a little more. I think this would be my big wish. Not necessarily only for myself, of course. I think we're going to be benefit of it, but I think for all innovators, also internal innovators that want to make it in mining, I think that would be very helpful.
No, I think that's a great point, because oftentimes the innovation focus so far, I think, has landed on the discovery side,
Hmm.
the finding new deposits, AI with predictive analytics and processing, or how you analyze geophysics and data capture through different sensor technologies. Like there's a lot of time and money that's gone into the discovery side, when it's the
Hmm.
processing that people have a negative association with in their mind, right? And yet there's less of an open innovate and modernize that part of it.
Exactly, and I think what's the key there is to understand, because I understand fully the reluctance of like a process manager or a process superintendent to let somebody else go into the process. And we didn't expect that, because what we're asking mine to one of the most decisive processes, like most critical, most expensive. There's so much energy and chemicals and resources going to that. We're like, oh yeah, we want to change it. What we can just simulate it, and this is what you can do with most digital technology. You can simulate the impact. You can do data collection. You can just see like what would happen if.
Yeah.
And that doesn't mean that you have to change anything in your process. And I think this is the most resource intensive, because for the discovery, it makes a lot of sense, because you spend a lot less time and a lot less money. But I would say discovery or like development, prospecting versus production, I think the environmental footprint is very different. Like you can do a lot of drones now, or satellite imagery. You can do already get a lot of understanding. What would be interesting and what not. But for production, it's still very. Sometimes I feel like when I go into someone and say like, why you do this way? It's like, we have always done it like this. Like, yeah, sometimes we're still we need to get out of the dark ages.
Yeah, absolutely. Well, cheers to that. Even though we're both having coffee this time. Thanks so much for coming on the rocks, and we look forward to keeping in touch and hearing what you guys do.
Yeah. Thanks so much for having me, Emily.